Okay, um, solving linear systems by elimination, day 2. So it's important to note that this is day 2 because it's very similar to day 1 except for one little thing. So let's recall here. Elimination is a method of removing a variable from a system of linear equations by creating some sort of equivalent system in which the coefficients of one of the variables are opposite. And what we talked about was that the variables they match, right? Like if the variables are 4x and 4x, we're in great shape, right? We'll be able to subtract those two equations from one another, and we'll kind of be on our way. Now, there's some new terminology here. An equivalent linear system. An equivalent linear system is when you multiply one or maybe even both of the equations by some sort of number other than 0, and you'll create an equivalent linear system of equations that has the same solution as the original. So essentially what we're saying here is that if you multiply a linear system or like a linear equation by a constant term other than 0, it doesn't actually change the line or the function. It just makes it like a multiple of the original. So in this particular example, they want us to solve the linear system using elimination. And if you notice that the equation 1 is 2x plus 5y equals negative 26. And equation 2 is 3x minus 4y equals 30. Now notice how the x's don't match up and neither do the y's. Neither of the variables match up. So you might be thinking, this probably is not a good, probably not a good question to be doing elimination. Well, if you look closely, um, we kind of choose to eliminate the y's. And as of right now, the y's are not matching. However, if you think about it, we've got a 5y, and over here we have a minus 4y. So we got to think of the lowest common multiple between 5 and 4. And a lot of students might get that by saying, oh, okay, well, 5 times 4 is 20. All right, so if the lowest common multiple between 5 and 4 is 20, then how do we make this 5, right? How do we make this 5y a 20y? Well, we're going to have to multiply it by 4. So that means we're going to have to multiply the first term, second term, and third term all by 4. Likewise, in equation 2, we're going to have to multiply, if we want to make this 4y a 20y, we're going to have to multiply it by 5. And if we multiply that by 5, we got to multiply each and every other term by 5. And that's what's going on right here. So we've taken this times 4 and we multiplied each term in the equation by 4. And over here, times 5, we multiply each term in the equation by 5. And then we have this, what we call equivalent system. So 8x plus 20y equals negative 104 for equation 1. That system is equivalent to that original one there. And same with equation number 2, right? We have 15x minus 20y equals 150 for equation 2. And that equation is equivalent to this equation here. Now notice, we have 20y and 20y. And the first one's plus 20y, the second one is minus 20y. So because the signs are different, if we were to add these two equations together, using this exact same method we used for elimination day 1, we would be able to eliminate the y, solve for x, and just be right on our way here. So let's see what a full example looks like here. So it says you're solved by elimination, and if you look at the system, we have equation 1, which is x plus 2y equals 10, and equation 2, which is 4x minus y equals negative 14. Now, at this point, you notice that there's no matching coefficients for the x's or the y's. You can choose to eliminate either the x or the y. I know in this particular example, you see it here, I chose to eliminate y, but you don't have, you could have chosen to eliminate x and you would have got the exact same answer. So because I chose to eliminate y, it's like, well, how can we make, we got 2y and that minus 1y. In this particular scenario, the lowest common multiple between 1 and 2 uh, looks like it's 2, because we can just multiply the 1y, by 2. So what we do here is, if we're going to do that, we have to multiply every term in the equation by 2. So multiply the 4x by 2, multiply the 1y by 2, multiply the negative 14 by 2, and equation 1, it doesn't really have to change at all. I mean, sure, if you really want to, you could say we multiplied it by 1, but that doesn't change anything, right? Like, really, we sort of did that, but we didn't have to do that at all. Multiplying by 1 doesn't change anything at all. So now we get this equivalent linear system right here. And the thing that's beautiful about it is that now we have the matching coefficients that we're looking for here. Plus 2y minus 2y. So from here on, we take these two equations and we say here we're going to add equations 1 and 2. And notice how we use a different color. We draw that line underneath the system here. And we just add just like we did in elimination part 1. So 1x plus 8x is 9x. Awesome. So you kind of see that adding there. And then the y's, we know they eliminate, so 0y, I suppose, or even just 0. And then when we add 10 plus negative 28, we get negative 18. At this point, 9x equals negative 18. We divide each side by 9 so that the 9's cancel, and we get x equals negative 2. And just like we're used to, we're going to take this x equals negative 2 and sub it into either equation. Now, is there an easier equation to sub it into? Probably. I mean, notice here that I chose equation 1, this one here. And the reason why I chose that is because the numbers are smaller. They're all positive. It just felt like an easier one. You can sub it into any which one you want. You could have subbed it into equation 2 down here. And you could have also subbed it into the equivalent system if you wanted to. But I wouldn't suggest that just because you'll be working with larger numbers. So when you have a variable here, sub it into the original. You use the original equations only because the numbers are smaller. So we sub in that negative 2 for x, and we solve. Isolate y, divide each side by 2, and y equals 6. And then, of course, we always state the point of intersection. X is first, y is second. Okay, maybe let's try some real examples here. It says here, solve by elimination and check. So we kind of have to make, at this point, we look at this system, and there's no matching coefficients, right? 3 and 2, 5 and 1, like that's not, it's not ideal. But what we now know is that we can make a decision whether we want to eliminate x's or y's. It's up to us. Now, you could eliminate the x's here, no problem. But I'm going to choose to eliminate the y's. And the reason why is because I see a 5y in the equation 1 and a 1y in equation 2. So I'm only going to have to do a little bit of work here. And when I say a little bit of work, I'm only going to have to multiply the second equation by 5. Because if we multiply each individual term by 5, then what's going to happen is that we don't have to multiply that first equation by anything at all. Right? So let's go ahead and see what these equations will look like over here. So the first one is not going to really change at all. But the second equation, we're multiplying each term by 5. Now you could express it this way. The only reason why I have it expressed this way is because I'm on a computer. But you could just write, okay, times 5, and times 5, and I'll get the idea of what you're doing. And you might even just state that way over here. So our new system is going to be here, right? 3x plus 5y equals 12. That one didn't change. But the bottom one here, equation number 2, is 10x minus 5y equals negative 25. Great. So yes, we chose to eliminate y. And if you look over here, look at this. This is so good. we've kind of forced the system to have those matching coefficients. So what we're going to do is, because the signs are different, right? Plus 5y, minus 5y. If we want to eliminate y, what we're going to have to do is add those equations. Yeah. So we write down our system, and I'm going to put a plus sign here, and I circle it. Yeah, just so I know what's going on. So we'll get 13x equals negative 13. We divide each side by 13. And then x equals negative 1. Great. Now, what we're going to do is sub x equals negative 1 into, well, I chose equation 1. Could have chosen equation 2 if you wanted to. You know that. You know it can go anywhere. So let's have a look here. Equation 1 is 3x plus 5y equals 12. We're subbing x equals negative 1 in for x over here. So we're going to replace x with that negative 1. And then we're going to algebra this thing right to the end. So we get negative 3. Bring that negative 3 over. It becomes positive 3. 12 plus 3 is 15. Right? We got 5y. So we're going to divide each side by 5. And y equals positive 3. So at the very end here, we can state our point of intersection and say that it is negative 1, positive 3. And I know the question says check, right? But we should always be checking our answers. And you know what? Maybe on a quiz or a test, I'd even give you marks for checking your answer. And when you do go and check these equations or check these answers, usually we always go back to the original. So if we wanted to write here check, so we're going to have to check equation 1, and don't forget to also check equation 2. We need to check them both. So equation 1, let me do this one. Whoa, okay. We need a restart. We'll save that for later. Let's change this to blue. So we got 3x plus 5y equals 12. And here's what I like to do. I like to go right down the equal sign like this. Make a little chart out of it. This is the left side, and this is the right side. Sorry about the penmanship here. So x is negative 1. 3 times negative 1 plus 5. Y is 3. So we're subbing in x and y here, and we're hoping that it equals 12. So we should get negative 3 plus 15. And look at that. It equals 12. Left side equals right side. And we're good. We're good on that one. Now, we have to also check equation 2. And I'm going to use the original here. 2x minus y equals negative 5. Here it is. And I'm going to split this equation up. This is the left side. This is the right side. So 2 times x is negative 1 minus y is positive 3. Okay, good. And we're hoping that this all equals negative 5. So we'll get negative 2 minus 3, which is in fact negative 5. So left side equals right side, and we're really happy about that. So because the left side equals right side in both of the equations, that's how we know that we got the right answer. There's going to be scenarios, you might find yourself in where it'll check out for equation 1, but it will not check out for equation 2. And that tells us that something went wrong in the math. It'll check out for both of the equations, and that's something to remember. Okay. Perhaps one more example here. Check out this system here. 3x minus 4y equals positive 7, and then we have 4x plus 5y equals negative 32. So we have to make a choice here. Do we want to eliminate the x's or the y's? In the previous example, it was nice because you could just multiply only one of the equations in the system by a constant. But in this particular scenario, I don't think we can get around that. So we should make a decision. Do you want to eliminate the x's or the y's? And I don't know. I'm going to choose to eliminate the x's here. And how might we do that? The lowest common multiple between 4 and 3. Well, I'm thinking in my head, okay, 4 times 3 equals 12, right? So it's like, okay, how am I going to make 3 a 12? Well, I'm going to have to multiply the 3 by 4, which means I'm going to have to multiply the entire equation 1 by 4. Likewise, for equation 2, how might we change the 4x to a 12x? Well, we're going to have to multiply it by 3. So we're going to multiply the entire equation here by 3. Okay, so here we go. First equation, 3x times 4 minus 4y times 4 equals 7 times 4. And then what's this going to look like over here? Well, it'll be 12x minus 16y equals 28, positive 28. So that is the new and improved equation number 1. How about equation number 2? Let's do this one in red. 4x, we're going to multiply it by 3, plus 5y, we're multiplying that by 3, equals negative 32. We also multiply that by 3. Lovely. So, whoops. Our new and improved equation 2 is going to look like this. 12, oh, why is it purple? I don't know. We want red. 12x, right? Because 4x times 3 is 12x, plus 5y times 3, 15y, equals negative 32 times 3, negative 96. Whoops. Great. So, this is our new and improved equation 2. If you look closely here, we're eliminating the x's. So, that being said, we might have to, because the x's have the same signs here, we're going to have to subtract. So 12x minus 16y equals 28. And then the other one is 12x plus 15y equals negative 96. So at this point, we know that we're going to have to add, and I highly, highly, highly suggest to just pull out a calculator here. Make life, ooh, I put add. Subtract, silly. We're going to have to pull out a calculator here. So 12x minus 12x is 0. 0x if you want. It's going to be gone though, which is lovely. Now, negative 16 minus positive 15 is negative 31y. See, that one almost tricked me. If I didn't use my calculator there, I probably would have said 1y. But because I used my calculator, I didn't fall into that trap. Now, 28 minus negative 96. Right in the calculator, it tells me it's positive 124. Okay. Now, the x is eliminated. It's no longer there, right? We're just left with negative 31y equals 124. Divide each side by negative 31. This penmanship, I'm sorry. I don't know why it's so shaky. Y equals 124 divided by negative 31. We get negative 4. Okay, so now that y is negative 4, what are we going to do with it? Well, we can sub it into either of the equations. I would not suggest subbing it in here because you'd be working with larger numbers, but certainly go back to the original equation 1 and 2 because the numbers are always smaller. So we can put a little header here. Sub y equals negative 4 into equation, I don't know, 1? Why not? I don't know what I did there. So 3x minus 4y equals 7. Yeah? And we're subbing in negative 4 in for y. Right? For y. Good. So 3x plus 16 equals 7, right? Because that's negative 4 times negative 4. And then we're going to bring that 16 to the other side. 7 minus 16. Let me go to my calculator here. 7 minus 16. Okay, so we got 3x equals negative 9. We divide each side by 3. And sorry, not negative 92, negative 9. I don't know what I hit there. Divide each side by 3, and we should get x equals negative 3. So therefore, we can say the point of intersection is at negative 3, comma, negative 4. Okay, so folks, the homework comes from the textbook, page 54 to 55, number 1, 3, 4, and 6. And I did throw a word problem in there. And in that word problem, you might have to create these, or create the system yourself. Could be a little bit tricky, but I do want you to try that because we are going to be going into word problems soon. Now, this extra practice handout, don't worry about this one because this is what we did the other day when we had that work period. Okay, so folks, if you do have any questions, please let me know. Send me an email. Send me a message on Teams if you'd like to chat on Teams. Let me know. Send me a message on Remind if you wish. I'm always here to help. Take care, and we'll see you next time.